A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, course instructor for the NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. Our today's lecture will be continuation of our lecture 26 under the module 11, where we were discussing about the pavement distresses, specifically about the causes and treatments related to some specific pavement distresses. At the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. Now, as we discussed in our previous lecture also, that it is very important to understand when some distress occurs on the pavement surface, specifically when some premature distress takes place, it is very important to understand the cause of those distresses, and then only we will be able to work it out a possible treatment for that kind of distress. We have IRC 82 which gives us the code of practice for the maintenance of bituminous roads. It is 82/2023, where the different type of distresses have been clubbed under different categories. The four main categories which are formulated are surface defects, cracks, then deformation, disintegration. In the previous lectures, we have discussed about the causes related to the surface defects, including the bleeding, smooth surface, streaking, hungry surface. Then under the cracks, hairline cracks, alligator cracks, age cracks, shrinkage cracks, reflection cracks. In today's lecture, we will focus specifically to the causes and treatments under the distresses which comes under the deformation, including slippage, rutting, corrugation, shoving, shallow depressions, settlements and upheavals, along with the distresses in the form of disintegration, which includes stripping, loss of aggregates, raveling, potholes and edge breaking. Now, coming to the first distress under the category of deformation, that is the slippage. We discussed about these distresses and their possible locations where they can happen and what can be the severity levels of these distresses. Today we will focus more on the causes of these distresses, and these are some of the common causes which have been experienced throughout these bituminous roads throughout the globe by different engineers, and some of the common measures which have been taken up by those engineers to address these distresses. Yes, but it is always very important and vital that the engineer in charge takes a careful look over the cause of that distress. These are some of the possible causes. There may be something else in addition to this particular one. So, he needs to investigate it in a proper manner, and then on the basis of this available information and his own judgment, he has to select a possible treatment for that particular distress. So, let us first begin with the distress which comes under the category of deformation is slippage, cracking, and we discussed earlier that it mainly occurs due to a poor bond between the surface layer and the underlying courses. So, there a slippage mechanism is there. You can see this is how a portion of the HMA surface has slipped and the bond has been lost between the underlying layer and the top surface course. So, specifically it occurs, when does it occurs? Mainly occurs when the surface loses its bond with the underlying layers. So, this can be possibly happen in case of omission or inadequacy of the tack coat, because tack coat is the one which is applied to build up a bond between the underlying bituminous course and the overcoming overlay of HMA. So, if there is an inadequate or an absence of a tack coat at some locations, there is a high possibility of slippage taking place. Or while we do a construction over an existing bituminous layer, it is always advisable and recommended that the existing base has to be prepared. That is, for any deleterious substances, it has to be cleared. For dust, all dust has to be removed, and then we go for an application of a tack coat followed by the overlay. So, if there is a presence of dust or moisture, then possibly you will not have a good bond of the overlay with your underlying layer, and if these are having say thin overlays are there and excessive deflections are there because the structure may be weak enough, then also possibility of this slippage may happen. And another concern is when these particular overlays or the top layers are over stressed by traffic, and specifically where it happens when you have these curves are there, some braking actions are there. So, there you have more amount of stresses coming up on the surface. So, a poorly bonded surface, specifically the one which has already having a lack of bond with the existing one, when it is overstressed by normal traffic, at what locations it usually get overstressed? At intersections, at curves where frequent acceleration, braking actions takes place. And along with when temperature changes are there, leading to premature cracking and material break off. So, with when these materials are highly stressed, and then these materials break and they peel off or they get separated from the underlying layer, which can quickly grow, especially in cold and if water comes at this particular part where the breaking has taken place, then this further get worsened, and this makes your slippage cracks more severe. So, what can be a possible treatment for it is involves, since the surface this particular section has been distressed, so it is important to remove this particular one, and while removing it we can mill it, and we will always prefer that it is milled up to a certain lower depth. We goes into the underlying course to a certain depth, so as to get a sound surface and with a good surface texture, rough surface texture specifically. So, what it says, treatment of slippage stress widely involves removing the slipped material, specifically what has already slipped, preferably with a milling machine. Small milling machines are there which can go for the milling of a given width, a small width, to a depth slightly below the point of slipping, where already this point is there. We preferably go because this is a polished surface it appears to be. So, we will prefer to go for a slightly more depth than this particular one to get a sound surface, and in addition that particular one, because when we do the milling it gives us a rough surface texture also. So, this is another and improves the bonding. So, then once we mill it into the sound surface to a certain depth, and if you mill it, then normally you get a rough surface also. Then you make the application of the tack coat, followed by whatever premix material which matches with the existing one is laid and compacted so as to achieve the required density. So, this is what a usual practice which is normally done. So, important aspect is we need to mill it slightly below this particular where with the this surface is already slipped off, and then a proper application of a tack coat followed by the whatever premix material which is compatible to the existing surface. Now, the other common distress under the deformation category where the shape there is some change in the shape of the pavement structure is rutting. It is a very common distress usually observed on bituminous pavements. So, rutting is the formation of ruts, specifically as we discussed it happens mainly in the wheel paths because of the excessive repetitions of the traffic loads. And in this particular one, if these ruts can accommodate water or water gets accumulated here, it is not able to go off with the help of the camber, then it worsens this particular damage. And rutting, under what situations or what are the factors which contributes towards the rutting is, first is pavement structures or materials cannot withstand the stresses. So, we design these layers considering a given strength. So, that particular strength which has taken for these materials during the design of the crust, if the materials are not meeting up those strength requirements, then they get overstressed, causing the densification or shear failure in the pavement layers. So, in that particular case you can see the densification, there is some underlying layer which is there. So, if this is a subgrade is there, here a granular course on the top, whatever layers, these may be multiple layers, but here we can see there is some densification which has happened in this particular layer. So, if the underlying layer is not properly compacted, this can happen, or within a layer also you can see this kind of failure where shear failure is there, the material is not having adequate strength to take the wheel load stresses. So, then it will show these kind of shear failures. So, this will ultimately create ruts or depressions along the wheel paths. Here this particular rut which has happened due to inadequate compaction at subgrade, in due course of time it will get reflected on your top courses. So, the rutting which appears on the bituminous courses is having a reason, cause which is lying at the subgrade level. So, this is an important aspect. What rutting which is visible on the surface, it is important to understand, and through for that particular one you need to have a trenches, you need to dig down some pits, you need to take the course and see where actually the rutting is happening. So, one of the reason is if these layers are over stressed or the layers are not having the adequate strength which is considered in during their design. Vehicle overloading, as we mentioned earlier also, this is one factor during the fatigue cracking, that when whatever the axle loads or the overloading factors which has been considered during the design, if the axle loads are more than that, if overloading is happening, then this would again lead to the failure of the pavement section in terms in the form of this rutting. Inadequate pavement thickness and poor compaction of layer, because then densification will take place. Excessive use of plastic filler and rounded aggregates in base end, because we have a restriction of how much should be the plastic fines should be there, that is in terms of the plasticity index of the granular courses. If that is not followed, in addition to that particular one, if rounded aggregates, because they do not have a good interlock, the internal friction gets reduced, especially in case of rounded aggregates, they do not pack well. So, in that case there are more chances that these materials will fail under the vehicular loading. So, that is why we have a restriction on the shape of these aggregates to be used in our base courses, sub-base courses. We have a requirement of the crust faces also when riverbed materials are used. So, that needs to be properly ensured. Weak subgrade and poor surface drainage. Subgrade, because entirely all our pavement crust layers are resting over the pavement subgrade. So, if that is weak, and if it is weak or if it is saturated also, and as we have discussed earlier that the subsurface drainage, the drainage layers which we provide over the subgrade in our granular courses plays a very important role to remove out, to exhale out whatever water which can enter from the surface cracks or which can enter from the sides also. So, if that subsurface drainage layer is not provided or it is not functioning, then the chances of, because these granular materials lose their strength in the presence of water mainly. So, then again you can experience this kind of shear failure and ruts. And when the rutting is specifically in bituminous courses, because nowadays thick bituminous pavements are constructed, the thickness may be varying from 20 to 25 centimeter, in that particular case 200 to 250 mm. So, when these thick asphalt pavements are there, in those they can also experience some ruts within the bituminous layers also. And what are the most possible causes of this rutting within a bituminous layer is excessive asphalt content. If due to any reason, if we design it for a higher asphalt content, this may happen if we have considered a lower compactive effort during the design of the mixes, and in field the compaction is higher or the loads which are coming up higher. So, then that particular one gets compacted, and this bitumen which has been considered for a lower compactive effort will become excessive in that case, or due to certain lack of control during the production of those mixes, the binder content has exceeded. So, then it is an excess asphalt content which will lead to these kind of shear failures. Higher filler contents, because these fines, specifically the one which are considered in bituminous mixes, fines are typically the one we have in the ranges of around say 80 to 100% passing through 75 micron sieve sizes. That material plays a very important role. We can reduce the air void content by increase of these materials without incorporating the binder, but then in that particular case the mixes becomes stiff and there is not that good cohesiveness in the mix. So, the filler content, a lower filler content as well as a high filler content, both are challenging specifically. And there are particular sizes, the fillers which are having sizes less than 10 micron can act as a part of binder extender also. So, this is another concern. So, the filler contents have to be properly controlled, because the fines which are collected in the hot mix plant through your secondary collectors, when they are reintroduced, the content of these fillers needs to be properly ensured that they are not exceeding the designed limit. Overuse of rounded particles, that is the same concern in case of bituminous courses also. We ensured in terms of their angularity also, fine aggregate angularity, coarse aggregate angularity, we ensured them in terms of the combined flakiness and elongation index also. Stripping in underlying HMA layers, what happens if there is water in the underlying layers has entered and your subsurface drainage is not working, then it rises up. The water rises as capillary rises there, and then it rises in the form of water vapors, and when the traffic load comes over it, a high amount of pore water pressure gets generated, and this starts inducing stripping the film of binder from your aggregates. So, the mix starts losing its strength. So, typically it starts from the underlying base courses, bituminous base courses which are in contact with your granular courses. And use of softer grade of binder, this is another one concern, if because depending upon the climatic regions, the maximum temperatures which are expected in a region along with the vehicular loads, we select a binder grade. If we select a softer grade of binder, then also the mix will show this kind of deformation. So, if this happens, as I mentioned, there are a number of causes which are there. So, one needs to work it out, that which is that particular cause which is there, which is that particular layer in which the rutting has been taken place. So, this you can see in this particular picture here. In this one, the surface course thickness more or less remains same, but you can see the thickness of your base course, bituminous base course is adversely changing. So, this shows that there is rutting which is taking place in your bituminous base course. So, that needs to be addressed. Only putting up an overlay may not serve the purpose. So, that is why by cutting down the trenches, by taking the course, you can work it out and you can see if any stripping has taken place. So, one important part, if you are able to figure it out, okay, this has happened in your bituminous base courses, now that needs to be removed, milled off. So, milling and replacement, any rut affected layer must be completely removed, because it has already distressed. Now, it will not serve the purpose. And we need to put a more stable mix over it. Patching, if some localized ruts are there, then they can be filled with the premix patching material and compacted to the required density. But if this rutting as it has happened in the subgrade, then that definitely indicates that this subgrade is overstressed and you have a weak pavement structure. So, simply just putting up thin overlays will not serve the purpose. So, in this particular case, you need to work out you need to go for the structure evaluation to work out the existing strength of the pavement structure, and then you have to design an overlay to meet the design traffic over this particular one. So, this is the overlay thickness has to be designed considering the strength of the existing pavement structure. Now, the other kind of deformation which can occur is the form of corrugation which is there, where again whatever the forces which comes on the bituminous surface, top surfacing usually when it exceeds the shear strength, and if it is happening in the HMA, we say that the shear strength has exceeded the strength of your HMA mixes, or it has exceeded the strength of your underlying courses. You can have this wavy like structure, or ridges are formed over the surface which is perpendicular. You can see these ridges are formed and which are perpendicular to the direction of the travel or to the direction of the shear forces. What are the causes are very similar to the causes which we experience in case of rutting. So, it happens mainly due to shear flow of the mix when the applied forces exceeds the shear strength of your material. Now, where it can happen? If it happens in HMA mixture, typically the reasons are quite similar to what we have for rutting. Excessive binder content is there, high percentages of fines or excessive filler is there, smooth or rounded aggregates are there, improperly crushed aggregates, as we have that okay, this many percentage of aggregates should have at least one fractured face or two fractured faces. Use of soft or incorrect grade of binder is there, inadequate compaction is there. This is another concern which is there. So if these layers are not compacted in not compacted way, when so their density is less, their strength is less. So when traffic comes over it, you can experience this kind of shear failures. Another concern may be in terms of the inadequate rolling or rolling a tender mix. So specifically when rolling is not there, densification is not there, or what is happening, a tender mix is there, usually a mix which is difficult to compact, which flows when you are compacting it at higher temperatures, or when the wrong grade of binder is there, these mixes are tender and difficult to compact. So then they can contribute these kind of ridge-like structures specific, and this can even happen at lower layers during the construction itself. So additionally, vehicle braking on gradients happens, especially near intersections, often accelerates their development. So this even you can find these corrugations specifically when some gradient is there, when downward gradient is there, and some bus stops are there, intersections are there, where some frequent applications of brakes are there, or some acceleration activity is happening. Now, what to do, or what are the conventional treatment practices which are followed in case of corrugations are scarifying the surface, because that has already a wavy structure, ridges are formed, so it has already distressed, it has, so that needs to be first removed, scarified, and part of the underlying base also, so as to get an intact surface. So it has to move so that at least to a certain depth of the intact, and then laying a new surfacing loads, because this will help us to get a good bond with the existing pavement surface. Alternatively, high spots can be milled or cut with a blade. We have drag spreaders are there, so they can spread the mix. Along with that, they can cut the surface, whatever the ups are there, they can be cut down. And this can be done with heating also. We will discuss these heating arrangements when we will discuss about the recycling of the asphalt pavement. So the surface can be heated up, and the high spots can be cut down or milled up and corrected with a leveling course, and then on the top we put up a leveling course. Another effective method is spreading a sand bituminous premix. If this corrugation is not high enough, we can go with the placing of a sand bituminous mix with a drag spreader, where it can cut the high spots simultaneously. In all cases, the treated area is finally compacted thoroughly by rolling to restore the same surface. So finally it has to match with the existing surface. For severe corrugations in the lower pavement layers, as I said, this can happen even during construction also, if with the movement of the construction vehicles, and many a times during the construction itself the traffic start plying, so these layers gets overstressed. So the corrugations may happen during the phase of construction also in certain layers. So in that particular case, a structure evaluation is to be carried out, and then followed by the reconstruction. There the overlay thickness has to be worked out with proper. And one important aspect is, if this is happening, corrugation is happening, and during that particular evaluation exercise, if it is found that the subsurface drainage is not adequate enough, it is not serving the purpose, it is choked, then during this particular strengthening part, it has to be taken care that how the subsurface drainage can be improved in the existing pavement. Now the other distress which comes under the category of deformation is shoving. You can see there is a shift of this mix which has happened on the edges. So this is clearly visible by the pavement marking which is there. So there is some mix which got shifted towards the edges, and some bulging has happened here also you can form. So this sort of distress you can very well experience, especially at intersections where they are there, or where some bus stops are there, or truck laybys are there, where the slow moving traffic is there and it makes frequent applications of brakes. So shoving is a plastic deformation in the bituminous layer that causes surface bulging, usually at intersections, sharp curves, and heavy vehicles frequently accelerate or stop. So now The reason specifically because the mix is unstable, how much the shear stresses which are coming upon the mix are quite heavy compared to the stability of the mix. So, the mix fails, and again if it is if this shoving is there in the bituminous mixes, the possible reasons are excessive binder, excessive fines or rounded aggregates, or use of a softer binder in the surface or a bituminous bound base course. So, these are some typical we can see in case of a bituminous mix fail, one reason may be excess of binder is there, second reason if rounded aggregate particles are used, excessive fines are used, or a softer grade of binder is used. So, these reduces the stability of the mix, and then the mix may experience the deformation in the form of rutting, also experience the deformation in the form of shoving also, or corrugations also. Poor bonding between the, again if there is not a good bonding, it may after a certain extent it may lead to slippage also, but since there is, if the bond is not that good enough between the underlying layer and the top layer, the chances of shoving is more. Heavy slow moving traffic, especially on curves and gradients, leads to these kind of failures in the bituminous mixes. So, this is one of the reason, that is why on horizontal curves or at gradients where frequent stops or acceleration are made, where we can experience these kind of distresses in the form of shoving. What is the treatment? Specifically, since this distressed part has to be removed. So, this has to be carefully identified, what particular section is there which is has been affected by it. So, that needs to be clearly removed, and we will prefer that it is removed to particular depths, a slightly a depth in the underlying course where you get a good stable base, and then we put up the application of the tech code, followed by the application of that premix material and its compaction. Now, other form of deformation is shallow depressions. At certain locations we can find some small localized depressions are there, usually around say 25 mm or 30 mm depth may be there. So, some localized depressions may be there at certain locations. So, these are specifically some localized distresses are there, and this is, so these are localized settlements and in the underlying layers of the pavement structure, and if it is these bituminous pavements are thick enough, it may be in the bituminous layers also. And the one common reason for this particular one is the inadequate compaction of the subgrade or insufficient densification of the subsequent pavement layers during the construction. So, some localized points are there where some weak materials or saturated layers are there which are not properly compacted. So, they are weak, or the bituminous courses at certain locations they are not compacted, because we usually try to compact them in air void content of 6 to 8% after rolling. So, if those air void contents are more than that particular one, they get compacted. We can feel these small amount of depressions, localized depressions may happen. Over time, since if underlying layer also if not properly compacted, then it is not going to get supported, will provide the required support. There will be a subsidence will be there, and this subsidence in any underlying layer in sooner or will get reflected on the top course. Over time, these weak spots lose their uniform support capacity and causing the pavement to gradually deform and form depressions on the top layer. So, shallow depressions in asphalt pavements are typically corrected. We can correct them by filling the affected areas with a suitable premix material, followed by a thorough compaction, so as that the surface matches with the surrounding material. So, this is how it can be repaired. These are shallow depressions. But when there are major settlements or upheavals are there, then you need to be more cautious about it, because the reason may be there is some major distress which is happening, because of which you can see a big settlements has taken place. So, these are large surface deformations compared to shallow depressions and usually indicate deeper structure deficiencies in the pavement system. So, and what can be there if large fields are there, if there has been a good amount of embankment construction have been involved in it and that has not been done properly, then again this kind of big settlements may take place, especially when it can happen along the near the bridge abutments or where some utility cuts are there, because there those fills are done in large quantities and not chances are there they are not compacted properly. So, or what can be there, another key reason, excessive moisture in subgrade and inadequate subsurface drainage. So, your subgrade is saturated and the drainage through your subsurface layers is not proper. So, then this combination always leads to this kind of major settlements or upheavals. Now, because when the water freezes, specifically in colder regions, you can find, and when you have soils or granular materials with higher amount of plastic fines, then and with which are not well compacted, then upheavals are observed. So, if settlements of upheavals are observed, the defective fill material should be excavated. We need to go deep down to the layer where actually this is happening, and that needs to be removed, replaced, and if it goes deep down, we have to take care that we are ensuring that the subsurface drainage is not getting affected. That has to be properly maintained. So, the material which has to be used during the backfilling of it should match with the materials of the existing one, so that this defect can be properly addressed. If inadequate pavement thickness is responsible, if one works out that this major is happening because the thickness of the pavement crust is inadequate to the traffic, then definitely structural evaluation has to be done to work out the desired overlay thickness. Now, the other category of distress, which is our disintegration, under which the one most common kind of distress which is observed is stripping. As the term indicates, it is the removal of the binder from the aggregate surface. So, this is when the bond between the aggregates and binder is lost, stripping takes place. And when can it occur? Because once this bond is lost, the material loses its strength, and then you can experience the distresses in the form of cracks also, in the form of rutting also, in the form of shoving also, because the strength or stability of the mix is lost because binder has stripped from the aggregate surface. So, when can it happen? One is poor drainage, because when the aggregates comes in contact with the water. So, from where it can come? Inadequate surface of surface drainage is there. If proper camber is not there from the top, then the water can percolate, will be in contact with the top surface for a longer period of time. If some fine cracks are there, it can ingress through those cracks also. And if subsurface drainage is not good enough, then water will rise from the this capillary water will rise, it will fringe, the vapors will be there, and a good amount of pore water pressure will get created under the traffic. So, that will lead to again stripping, which will mostly happen from the bottom of your bituminous courses, because more chances of water is there from the underlying courses. Inadequate compaction of HMA mat, if it is not compacted to, as I mentioned, we expect to have 6 to 8% of voids when it is compacted, but if it is compacted to inadequate density, because at 6 to 8% air voids, these voids are generally not interconnected. So, you don't expect water to enter into it, but say the voids may be say 12-13%. So, then the water enters into your HMA mat, and that leads to the stripping of your bituminous binder from your aggregates. Presence, another concern is when you are using these aggregates, and if there is a good amount of dust coating which is present over it. So, at HMA plant, if you are finding that the dust coating is higher over the coarse aggregates, will prefer to first of all to go for wet sieve analysis, and then it may be desired that you can sprinkle water over the aggregates to remove that dust film, so that you get a good coating of bituminous binder over your aggregates. So, that may create a hindrance between the bond of your bitumen and the aggregates, and the binder may develop a bond with the dust coating, which may get easily removed in the presence of water. Second is high residual moisture in aggregates during mixing. Certain aggregates which are specifically, it can happen during the rainfall events. So, in that course of time, if there is during the production process, if still the moisture is there in those aggregates, then again there are more chances of stripping which can happen. Overheating of binder or aggregates during, because this specifically leads to aging of your binder, and this the binder which has aged one forms a coating of the aggregates which is more susceptible towards the stripping. Use of weak and friable or hydrophilic aggregates, this is the other category, because when these aggregates are weak enough, they gets broken up and then they expose the surfaces where more chances of entering of water is there. So, more chances of stripping takes place when these new faces gets opened up. Continuous water contact with the coated aggregates. So, this may be there from the underlying water also and from the top also. So, whenever this specifically we can understand, if the coating is not proper, that may be due to the presence of dust, or if the water reaches to the this surface and in the presence of water the binder film gets stripped off. So, that leads to this stripping distresses. So, that is why it is always when we see these kind of distresses on the surface, it is recommended to mill the stripped bituminous mix and replace it, because the stripped has already lost its strength. So, it is no longer recommended to keep that particular mix. It is preferred that the one which has already stripped should be milled up and a fresh one should be laid. And during the construction, it is always recommended to employ a suitable anti-stripping agent, because there may be many aggregates which are not found good enough for this stripping resistance. So, in that particular case, we can preferably use an anti-stripping agent. Liquid, quite a good number of liquid anti-stripping agents are popular, but their dosage is again important, because low doses may not serve the purpose, may not be effective, and if higher doses are there, many a times it leads to a reduction of the strength of the mixes. So, the doses are to be carefully decided during the mix design. And another is a very lime is a very popular anti-stripping agent which is preferred. So, during these mixes which are used for treating the surfaces which has stripped, in that particular case for those aggregates, lime can be used as an anti-stripping agent. It has been very effective. Regenerating sealings, and once it has been removed, we have observed some stripping has, if it has happened to a lower severity, we can go with some slurry seal or micro surfacing over those stripped surfaces. And if we are experiencing that there is a major challenge which is present with the subsurface drainage, and the structure evaluation is carried out and an overlay is decided, in that case we will prefer that this, whenever we go for a dense HMA overlay over an existing pavement which has having a severe stress in form of stripping, we will prefer to put a layer specifically which can serve as a drainage layer, so that it can protect it. So, a drainage which can be in the form of a geocomposite layer can be there, or an aggregate granular layer as a drainage layer needs to be provided, so that whatever water which is already entrapped inside the existing pavements goes through that particular drainage layer and does not again affect your overlay. Now, the other distress which comes under the category of disintegration is raveling, specifically where the progressive loss of fine aggregate particles and binder takes place from the bituminous surface. You can see here it looks that fines have been lost along with the binder. So, again what can be one reason, because one reason can be the inadequate or the improper filler bitumen ratio. If this is very high, the filler bitumen ratio, then you do not have a proper good cohesion in your mix. So, that is, if this is very weak, the stability is very low, the stability may be a concern. So, that is why during a mix design we try to keep the filler bitumen ratio in a particular range. Overheating or excessive aging of bitumen, so that makes your binder more hard, it ages your binder more, and then the adhesion between your aggregates and binder gets weakened up. Use of weak, highly absorptive or easily fractured aggregates, because then these are aggregates gets broken up and they are highly absorptive. So, the effective binder film thickness gets reduced. So, then also this raveling can be experienced. Harsh climatic conditions can be there if surface voids are there, slight surface deformations are there, cracks are there, and under these rainfall events some freezing happens, then it fractures, it breaks your fines, and specifically it can lead to the raveling. And it can also happen if some construction activities have been taken up in cold or wet weather conditions when the compaction is not done properly, and that retains the water in those surfaces. Inadequate camber, because this is another concern, we nowadays construct wider pavements, 6 lane, 8 lane pavements are constructed. So, if the camber is not proper, then the water remains for a longer duration over the surface when it moves towards with the help of the camber to the sides. So, in that case, with this longer exposure of water, these bituminous mixes to water, they can introduce this stripping from the top, and that may lead to the raveling. And another concern is heavy stresses, specifically when it is more at some turns are there or where some braking or acceleration actions are taking place. So, what is usually done if you experience this raveling where some loss of fines and aggregate? The one commonly is, if the severity is low enough, we can go definitely with a treatment of a fog seal, that is a low application of a low viscosity emulsion is there. If we find that this severity is high, there is a loss of fines which are to a higher category. So, then we go for specifically for an application of a slurry seal or micro surfacing. The details of this we will discuss in the upcoming lecture. And if high severity is there, then possibly you can go for thin HMA overlays, or you can work for the higher thicknesses of your micro surfacing or slurry seal for treating the raveling. Then once these stresses are getting exaggerated or higher severities, in certain cases these pothole formations are also observed on bituminous pavements, which are specifically small holes that extends through the mainly through the HMA surfaces and can go up to your subbase or base courses specifically. Now, when usually this happens is when you have thin HMA overlays are this is a very frequent problem which we can see when in MDRs or other categories of roads which are having a thin HMA layer only to withstand the traffic loads are quite heavy. So, in that particular case those layers experiences cracks, and very frequently those experiences these pothole formations also. Now, when these thicknesses are less, crack formation may be there, and as we have seen, crack formation, fatigue cracking is there, longitudinal cracking is there, transverse cracking are there. When these cracks are formed, water enters into these cracks. Through these cracks will soften the base and weakening the pavement structure. So, then it will reflect more amount of stresses will get generated and it will further break down. So, the cracks get more widened up, and these cracked pieces may be in due course of time will be picked up, because closely spaced cracks will be formed and they are going to be picked up by tires, and along with it, as since water has gone into the underlying layers, fines will start coming out of it, and this creates the loss of support from the underlying layers and finally initiating the formation of potholes. So, this is an accumulation of factors which takes place, which starts with small depressions, small cracks, and then ultimately leads to the formation of these potholes. So, extended water exposure of bituminous layers under traffic, primarily due to poor camber, surface depressions, small surface depressions, higher voids are there compacted to a lower density, reduced cohesion can cause stripping, raveling, and finally aggravates your rutting and cracking, ultimately resulting in your potholes. So, when you have these combination of factors, specifically if some cracks are there, ruts are there, depressions are there, and the water stands over this particular one, then the stripping, raveling takes place, water enters through your cracks, weaken your subbase, and then finally more amount of deflection is carried out, the crack intensity increases, and these pavement breaks, and these pieces may be cracked pieces may be picked up with the traffic, and ultimately these formation of potholes takes place. what can be the suitable treatment. The important part is whatever the affected area need to be carefully marked and the material has to be removed. And thereafter nowadays we have good amount of cold patching mixes. We have certain ready-made mixes also which can be stored for a longer period of time, and if the weather permits we can go for the hot mix asphalt also. So it needs to be properly prepared, the pothole needs to be properly prepared, and we have suitable equipments also to fill up these potholes with these patching mixes, cold mixes, and then it needs to be compacted so as to match with the existing surface. So this is how the pothole patching can be done. Now the other distress which is usually observed in the term under the disintegration is the edge breaking. You can see here the pavement edges, very frequently we can see on many roads that the edges gets breaked up, specifically pavement edges gets breaked up in an irregular manner. So, and what can be the reason behind it is, one is because these edges are more exposed towards water. So infiltration of water from the pavement edges or sides. So if the side slopes are not good enough, water will enter into a pavement crust from the sides, and this will weaken the support. So infiltration of water from the pavement edges or sides, which weakens the foundation layers and causes the edges, the support from underlying the edges will get reduced because of the presence of water. Worn out shoulders, these shoulders provides a good support to your pavement edges, but if the shoulders are not properly maintained, then in that particular case the side support is lost, and which can further aggravate this particular problem. Inadequate compaction, usually because what's the problem whenever the edges are compacted, because lack of confinement at the edges leads to a lower density of the edges. The material on the edges in most of the times, if proper measures are not taken, then they get compacted to lesser densities compared to the middle part of your carriageway. So this again leads to these edges, breaking of the edges. And many a times when the pavement width is not sufficient enough, so the wheels are plying over the pavement edges, then this again, because which is not protected by the shoulders also, then these edges gets breaked up. So narrow pavement width, where the overall width of pavement is insufficient to withstand the traffic stresses, also contribute to edge failures. Then since how to rectify this particular one, we need to remove the edge as well as the shoulder materials where we observe these kind of distresses and they are removed to a particular depth where you get a sound base in that case. And then we need to reconstruct both the pavement at the edges parts, and the shoulders are then need to be rebuilt simultaneously, ensuring thorough compaction throughout. So it needs to be taken up in layers, because this if it has gone deep or otherwise for whatever thickness of bituminous it has gone down, that has to be milled up, and then the construction of the subgrade and this particular one, your carriageway, has to be taken up simultaneously. A new bituminous surface matching the adjacent stretch is then laid. The shoulder should be constructed with an adequate slope. This is again an important aspect. Usually whatever earthen shoulders are there, they have typically a camber which is around 1% more than the camber which you have on your carriageway, so that the water can quickly get removed, and the material has to be properly as per the required guidelines, the shoulder materials. It should not be that the shoulder materials are of inferior quality. So in that particular case, they will hold the water there. So we need to have a proper camber, a properly designed shoulder material, so that water gets quickly removed from the pavement these shoulders. If it stands there, the shoulders, again it will enter into your edges near the pavement edges, and again the edges may get weakened up. So to avoid reoccurrence of edge failures, regular maintenance is essential, because if it is open land, open trenches are there, fine enough. If it is in urban sections, the side drains needs to be regularly monitored and it needs to be regularly cleaned up. So it requires including periodic inspection of shoulder conditions and timely replacement, because these shoulders with the movement of the vehicle tires in case of emergencies may get distressed up. So they require a regular maintenance also. so as to get the edges protected. So, this is all about some of the common distresses, their possible causes, and what are the treatments which can be used in this particular one. And as I mentioned, it is always important to, for any kind of distress which has taken place, to work out, to carefully work out the possible causes through various investigations, and we have already a list of causes which can be there for a particular distress. So, on the basis of that experience, the different causes can be worked out, understood, and then from the possible treatment which has been done for that particular distresses, one can be picked up considering the actual field situation. So, this is all for today. Thank you so much.